Today we are going to study about ionic bond. Ionic bond is also known as electrovalent bond. Ionic bond is formed when oppositely charged ions, cations which are positively charged ions and anions which are negatively charged ions are attracted to each other by electrostatic force. Here, transfer of electron takes place. It takes transfer of electrons from the cation to the anion ions. So let us understand it by some examples. Example number one, NaCl, that is sodium chloride. Now the electronic configuration, first of all the atomic number of sodium is 11. So the electronic configuration of sodium will be 2, 8 and 1. Chlorine, atomic number of chlorine is 17. So electronic configuration of chlorine is 2, 8 and 7. Now we write Na and we will show this one electron in the outermost orbit of sodium. Whenever we are talking about bond formation, we'll always discuss the outermost shell. For example, in Na we talk about 1 and in chlorine we'll talk about 7. So let's show the electron by sodium electron, 1 electron by making a dot. So this is sodium with 1 electron. Chlorine. Chlorine we can show cross to show different set of electrons for different element. So chlorine 1, 2, 3, 4, 5, 6 and 7. Now we can show this transfer of electron this from sodium to chlorine. This arrow shows you the direction of the transfer of electron from the cation sodium to the anion chlorine. Further, we can enclose sodium in a square bracket showing a positive sign there. That means one electron has been transferred from sodium. We can also write its electronic configuration now. It becomes 2,8 because it has transferred one electron to chlorine. You show a plus sign and then again a square bracket showing chlorine. How many electrons? 7. 1, 2, 3, 4, 5, 6, 7. And we can now show the transferred electron of sodium with a dot. Now the electronic configuration becomes 2, 8, 8 because it has got one electron from sodium and the charge of this chlorine will be negative. Therefore, we have the elements NaCl, Na positive and Cl minus. So this is how we can show the ionic bond formation of sodium chloride. In another way, we can also show this in another way how the bond formation of sodium chloride takes place. So we can make two circles showing you the element sodium and element chlorine. Then we can write down sodium in the center and show its electron with a dot. Then we can write chlorine in another circle and show its electron by showing the crosses, by making the crosses 1, 2, 3, 4, 5, 6 and 7. Then we can again show the arrow showing the transfer of electron. Finally, we can show them. Again, sodium we can show in a square bracket. And we can put a positive sign telling us that it has transferred one electron. And then we can make another bracket. We can draw a circle over there this time. And then close the square bracket. Inside the circle, you can write Cl and then electrons of chlorine, 1 2 3 4 5 6 and 7, and the electron transferred from sodium, we can make a dot. Now chlorine has 8 electrons, and we can put a charge over there. We can show a charge over there. So this is how sodium chloride is formed, by ionic bond, by the transfer of electrons. Let's go to example number 2. Example number 2, we have magnesium chloride. So first of all, let's write down the electronic configuration of magnesium. Magnesium atomic number is 12. So electronic configuration will be 2, 8 and 2. Chlorine is 17. So 2, 8 and 7. Now we can show magnesium Mg, and we can put 2 dots showing 2 electrons in the outermost shell. Again, here we are talking about only the outermost shell, 2 for magnesium and 7 for chlorine. So magnesium 2 electrons, and then chlorine Cl, we can make 1 2 3 4 5 6 and 7. Another chlorine, 1 2 3 4 5 6 and 7. Now we can show the transfer of electron. We can first make the electrons over here, and then we can use the red to show the transfer of electron. So both the chlorine gets 1 electron each. Then we can enclose magnesium in a square bracket, writing 2 plus, because that's the charge, because it's giving 2 electrons, or 2 electrons are transferred to chlorine, 1 to each chlorine. There are 2 chlorines, so 1 electron each to each chlorine. So now its electronic configuration becomes 2 and 8. And then we can write 2 and square bracket. Why 2? Because there are 2 chlorine. Enclose chlorine in a square bracket, and then we can write down the electrons with a cross, 1 2 3 4 5 6 and now 7, and then we can show the dot of the magnesium electron that is transferred, and here we write a negative sign. Now the electronic configuration for this will become 2 8 and 8, because it has got 1 electron from magnesium. So therefore it forms MgCl2. Another way of showing this is again making 2 circles. It's for sodium, and then this is for magnesium, and then there are 2 chlorine, so we can make 2 circles. Now the size is the same, so we can do that. Yeah, now we can write down Mg. We can show 2 dots for 2 electrons, and then chlorine 1 2 3 4 5 6 and 7. 1 2 3 4 5 6 and 7. And then we can show the transfer of electron from magnesium. 1 electron goes to the first chlorine, another electron goes to the second chlorine, and then we can again show it in a square bracket, Mg. We enclose this into a bracket, square bracket, 2 plus for 2 electrons, 1 each to chlorine, and then we can write Cl square bracket, and we can show the electrons, 1 2 3 4 5 6 7 and 1 dot, and then another chlorine, because there are 2 chlorines, Cl 1 2 3 4 5 6 7 and 1 dot, and finally the structure is MgCl2. So this is the ionic bond formation of magnesium chloride. Next, let's go to another example. This time we have an example of calcium oxide. So again over here, calcium has an atomic number of 20. So 2 8 8 2. If you're not very sure of the electronic configuration, I will be doing a video on how to write down the electronic configuration with the rules. So you will become better at it. Ca2882 calcium, and we have oxygen. Oxygen again over here is 8. So 2 and 6. Now let's draw the electronic configuration. After the electronic configuration, let's draw the structure. So Ca, and we again concerned with the outside electrons, 2 and 6. So how many electrons are there? 2. So let's show 2 electrons over there. And then oxygen, 6. So 1, 2, 3, 4, 5, 6. And then we can show the transfer of electrons. And then finally we can enclose calcium. How many electrons is it giving? 2 plus. So now its electronic configuration will become 2, 8, 8. And plus, and then oxygen. Oxygen, enclose it in a square bracket. Oxygen, we can show the electrons of oxygen. 1, 2, 3, 4, 5, 6. And 2 electrons. And we write 2 minus here. Why 2 minus? Because it is getting 2 electrons from calcium. Now its electronic configuration becomes 2 and 8. So this is how we write down the ionic bond of calcium oxide. Another way of doing it is we just make circle calcium, and then we make circle of oxygen. Now we can make a circle like that, yeah, and then we can write down calcium. How many electrons? 2. We can make dots over here. And oxygen, 1, 2, 3, 4, 5, 6. And then show the transfer of electron by the arrow here. And then we can enclose calcium in a square bracket, 2 plus, because it is giving 2 electrons, plus we can put oxygen in a square bracket, and here we can show 1, 2, 3, 4, 5, 6, and 2 dots because 2 electrons it is getting from calcium. 2 minus over here because it got 2 electrons from calcium. So finally we have this formula of CaO. So this is ionic bond of calcium oxide. Now fourth example is magnesium nitride. So again we first of all write down the electronic configuration of magnesium. Atomic number of magnesium is 12. So 2, 8 and 2. Nitrogen is 7. So we write down as 2 and 5. Now how many magnesiums are there? 3 magnesium. So Mg, we have to write down 3 magnesium, and each magnesium has, we are only again concerned about the outermost electrons in the outermost shell. So how many electrons each has? 2. So 1, 2, 1, 2 and 1 and 2. Nitrogen, you'll see that they are 2 nitrogen. So we write down 2 nitrogen, and each nitrogen has 5 electrons. So we put a cross for each electrons. 1, 2, 3, 4, 5, 6. Sorry, 5, not 6 but 5. Another nitrogen. 1, 2, 3, 4, 5. Now we can put a cross, not cross, an arrow for the transfer of electrons. So 1, 2, 1 comes from the bottom, middle one, 1, 2 and 3. So each nitrogen is getting 3 electrons. So we can show it. Next step is enclose magnesium in a square bracket, and we write 3 magnesium over here. Why? Because there are 3 magnesium, and 2 plus. Why 2 plus? But each magnesium is giving 2 electrons, so 2 plus. Now its electronic configuration will become 2 and 8 plus, and then in the bracket we write down 2 here because 2 nitrogen is there. And let's show the electrons now. 1 2 3 4 5, 5 of nitrogen, and 3 it has taken from magnesium. Let's enclose it in a bracket. And how many each has taken? 3, so 3 minus. Now its electronic configuration will become 2 and 8. We can also show it by another method. Let's do that. Make 3 circles. This is for magnesium, and 2 circles for nitrogen. We can rub this and make perfect circles. 2 circles for nitrogen. Now we can write down inside magnesium and show 2 electrons for each magnesium. Mg 2 electrons and Mg 2 electrons. And then nitrogen, we have how many electrons? 5. So 1 2 3 4 5. Nitrogen 1 2 3 4 5. Now we can show the transfer of electrons. 1 2 and 3. Here also 1 2 and 3. So this is how the transfer of electron is taking place. Now we can write the next step. 3 Mg in a square bracket is enclose it, and 2 plus because it is giving 2 electrons each Mg plus. And now you have to show 2 square bracket because there are 2 nitrogen. Each nitrogen has 5 electrons. So 1 2 3 4 5, and it gets 3 from the magnesium. Here also we'll write 3 minus because it's getting 3 electrons. Another nitrogen, enclose it in a square bracket. 1 2 3 4 5, and then 3 from magnesium. 3 minus because each nitrogen is getting 3 electrons. Finally we get the structure as formula Mg3N2. So this is the final formula of magnesium nitride. I hope you have understood it.